Alright, so here I am. I'm going to go over Unit 5 SAS 10, which is Concentration of Medicine. My objective here is to see how piecewise functions can be used in conjunction with other functions to apply to other applications. I will do my best not to try to sound too boring or not trying to now be pressured into trying to sound too funny because y'all make me all nervous now with the way y'all talked to me earlier. But anyways, so look, what we're looking at is like thinking about this. We want to do something where we're talking about like how much medicine you initially get. So let's say, for example, and you try to use this example to help you go through questions like 1 through, I'll figure it out. Anyways, but let's say take for example, you are taking say 50 milligrams of a medicine. Okay, and the doctor knows, maybe you don't, because obviously that's why they have you take the medicine, but the doctor knows, let's say that it burns off, or how would I say, it has a flush rate. That's what they're saying here, a flush rate. Well, that's kind of an odd term for that, but anyways, let's say 40%. Okay, so use this idea for helping you through the first few problems. Okay, so what I would do here, like let's say in day 1, obviously I take it, and I take my 50 milligrams. That's how much I have in my system at day 1. But day 2, I need to do the 50 milligrams times the 40%, because that's how much is, say, kicked out. Hold on one second, let me double check on that. And let me fix that. Okay, not that there's 40%, but okay, look. If I say I flush out 40%, that means I get to keep 60%, okay? So flush out, but this is what I get to keep. Or this is what stays in my system. I shouldn't really say keep. So this is what should multiply the 0.50. Change that to a decimal, of course. But then I'll take another 50 milligrams. So you see, like here, I took 50 milligrams the first day, and that's what was in my system. Of course, it burns out some of that, and we'll be able to show that in a function later. But if I take the next day, I'll take another 50 milligrams, but I still had 60% of yesterday's medicine in my system. When I do that, and say 50 times 0.6 plus 50, I get that I have 80 milligrams. Now, if you kind of recall, there was a recursive routine that we did that had something like that, where it was like a recursive routine. Where we said something like it was the initial amount times a certain percentage, but then we could add back in the initial, because this was like a decay, which means it was going to go down, but we're re-energizing it, I guess you could say, with some more. And if we kept doing that, we could actually set up a recursive routine where all we had to do was, let's say in this case, the initial amount, then we would enter, and then we would set the recursive routine. We would say times the percent plus that initial amount, and then you could hit enter many times. Doom, doom, doom. Okay, and that would help you fill in the table that you're seeing if you apply this idea to that thing. Now, like if you look here, and you can test it out here. This is day 3. Now I would be saying 80 times the 0.6 plus 50. And let me see what that is. 80 times 0.6 plus the 50. And I get 98. Well, that was horrible looking. Let's try that 8 again. Okay, 98. And then kind of go from there, right? So test it out. If you put in the 50, and then you press enter, and then you say times 0.6 plus 50, you get the 80, press enter again, you get the 98, press enter again, and you start seeing. So that would be a way for you to be able to fill in the table. So you should be able to answer question number 1 and number 2, fill in the table. And if you fill in the table, you should be able to answer question number 3, which would tell you when does it seem to level off. Because eventually what happens here is that when you take certain medications, they seem to level off. And so they would not be, it's not that they're losing their effectiveness, but that means now it's reached the rate of where it would have the maximum effectiveness for you. That's the reason why doctors make you take medicine for so long. And in some cases, a little too long, but that's a whole nother long story for me. So what would you expect a graph of the amount of sneeze be gone in the bloodstream as a function of time to look like? Explain your prediction. See if you can kind of graph that. Maybe be able to answer number 5 on your own. So right now, at this point, you should definitely be able to answer questions 1 through 4. Ah, dang naps in the biscuit here. Questions number 1 through 4. Okay, number 5, I want y'all to discuss and see if y'all can figure out what you would expect the graph to look like. Maybe even try to graph this if you like. But again, realize what we've studied so far is linear, exponential, logistic, sinusoidal, and I think that's about it. I mean, so think about along those lines. See if that helps you. Number 6, recall the general form of exponential k is a b to the x, where a represents the starting amount of the substance and b represents the rate of decay for a triangular graph. What exponential function could describe the amount of sneeze be gone in bloodstream as? Okay, so hold a second. Let me think about this for a second. Okay, I'll pause right now. Okay, so for question 6, they want you to like put this into that form of y equals a times b to the x power. Okay, a is the initial amount, so in this case 20. B is what? B is how much we keep in the bloodstream, which would be 0.7 to the x power. Okay, so actually that's just your answer for number 6. What exponential? So I didn't know if you. Well, I'm not going to even say anything. What I would like you to do though is, since the patient did not begin taking the medicine until day 1, subtract your function rule by subtracting x1 from the x1. Okay, so for number 7, they want you to graph this, but we're going to say since the patient didn't start taking medicine on day 0, it started taking it on day 1. So to show this effect, 0.7 to the x minus 1 power. Okay, graph that. Sketch your graph. Okay, try to make sure you have a graphing or window. Describe your viewing window to make sure what was your viewing window. Tell me what your x min, x max, y min, y max. How did that fit? Kind of go from there. And then let's look at the next part. Number 8 says if time x is given in terms of number of days, what happens to the amount of sneeze be gone in the patient's bloodstream at the start of day 2 when the patient starts the second pill? How does this affect the graph? Okay, let's talk about 8 and 9. What happens here in 8, okay, let's think about this. If you've got a graph, okay, you're taking, this is, let's say, your medicine graph. Okay, at the end of day 1, beginning of day 2, what's going to happen? Well, we now don't need this part of the graph. This is at the end of day 1, right? What's going to happen? We take another medicine, and it's going to jump back up, and we get a new graph, kind of like that, something like that. So the point here is what happens. Try to explain to me what we're doing here. Why is this happen? Okay, so in your own words, why is this occurring? Okay, I can't really explain this better, but if you do have questions, feel free to ask me when I see y'all next. Number 9 says, use what you have learned about step and piecewise functions in previous activities to restrict the domain of your graph. Sketch your new graph. Okay, so think about this. On day 1, we're using this formula. Y equals or 20 times 0.7 to the x power. minus 1. Okay, what is the domain restriction here? From when to when? That's what you need to put here. Your domain restriction is from when to when. And notice we usually start at 0 and kind of work our way that way. Okay. Day 2, number 9, or not, that was number 9, sorry. This is number 9, sorry. Day 2 says, okay, then take what you had, and instead of saying why keeping the thing, we now have 34, this is for day 2, times 0.7 to the x minus 1 power into your calculator. Okay, so now we have a piecewise function. So you've got to remember how to put this into a piecewise function. We're saying we had 20 times 0.7 x minus 1. And we have a restriction from when to when. Now we're putting in 34.7 x minus 1. And we're going to have to put in from when to when. And then let's try to do for 10 through, let's say 10 through, write a function data table. This covers 10 through 14. So we want to set up some more piecewise functions, and notice these will be restricted to a certain day and kind of go from there. Okay, so assume that this would be how much is in each day, like say day 1, day 2 in your system. So look at your table, but the 0.7 will remain, x minus 1, 0.7, x minus 1. And then see if you see a pattern, that will kind of guide this, and then we'll try to hopefully be able to go through this next time I see y'all. What I would also like you to do is go ahead and start doing this for part B. Something similar. Notice that now it's a 30 milligram dose of Sneeze Be Gone. Use a home screen recursion, so kind of follow what I was doing. And then at least fill in the table and how many doses, and see when it levels off, and then we'll discuss that a little bit further, hopefully that on Thursday. Okay, if you do have any questions, feel free to let me know. If I get a chance, I'll try to answer it. But anyways, thank you for your time, and I hope this proves very helpful for y'all as you're working through this assignment. Good luck.